Our next presenter is a Python Ruby developer originally from Wellington, but who now resides in Melbourne. He's the past organiser of the Wellington chapter of the New Zealand Python Users Group, and was one of the co-organisers of the Kiwi PyCon for 2011 in Wellington. To share his views on Python, Ruby and Go, please welcome Brett Wilkins.
Hello, thank you. So I guess we should probably start off with who I am. My name is Brett Wilkins. I am a New Zealander. As you can see, what most people call Australia is really just the western island of New Zealand. I am BJ Maz on Twitter, if you really care, and also B Wilkins on GitHub. The second link there, because I'll be putting these slides online, the second link there is my blog, which rarely gets updated. So why are you listening to me? Why, really? Actually, why you might want to listen to me, there are a few reasons. I'm the ex-treasurer of New Zealand Python User Group Society. I've previously ran Python User Group meetings in Wellington, and I've been to the dark side and tried the cookies. So what exactly am I talking about? Basically, I'm trying to talk about what's cool about languages I like. Actually, let's go back here and go down the way I'm meant to go. So yeah, there's stuff in different languages that make me happy. So really what that means is, this is a language comparison. So yeah, what's so cool about Python? Or what do I find cool about Python? All the Pythons. There are so many Pythons. You got CPython, which is the standard, or probably the gold standard. PyPython, or PyPy, sorry, which I've got to say is really cool. It's Python written in Python, if you will, then compiled down to C. IronPython, just leave this here, and Jython, which is the one I actually always manage to forget about. So I also think it's great that Python is explicit. What I mean by that is it's explicit with namespaces, and it's also explicit with functional method calls. So this is, of course, also said in one of the tenets of Python, according to the Zen of Python. Explicit is better than implicit. And that comes through in the language. So what I like about explicitness is, or the enabling of explicitness that Python gives you is that it shows or enables the display of intent. So I've got a bit of a code here. It's basically showing very intently, I'm only going to use image from PIL, and it shows you exactly what I'm doing. And of course I ripped that code from some random place. List comprehensions. God, do I miss these. After I learned Python in my first job, I moved on to another job, which required learning PHP. The knowledge of which, by the way, I try to deny as much as possible. But once I realized that I couldn't use comprehensions in PHP, I saw so many places that I could use them, if only I was using Python. Namespaces again. We're back to namespaces. So the way modules and namespaces operate in the language, once again, allow you to be very intentional. For instance, we have import sys. We're basically saying you're going to interact with the sys library through the sys handle. Then we have, from PIL, import image. In this case, we're displaying the intent that we will only use image object from the PIL module, which is exactly the same as was in one of my previous slides. And then finally, my, or perhaps our least favorite, from foo import star, which is include everything from foo into the current local space or scope. There's also a lot of non-web stuff Python. I'm a web developer, so I think it's really, what really interests me, usually when looking at something else, is not what I do for a day job. So what I'm talking about really is not that. particularly mathematics and scientific Python. A small sample of what is available in this space, we have NumPy, Number, SciPy, SymPy, SymPy, and Pandas, which I heard about on Friday. No, not there. So I've got a few slides on the drill down on what they are, but most of you probably know what they are. NumPy is a fundamental package for the scientific computing with Python. It provides optimized scientific primitives for Python along with functionality to perform advanced calculations. Building on top of that, we have SciPy, a library for providing fundamentals for scientific computing specifically. Then we have SymPy, which is a library for symbolic mathematics. I actually added this in with SymPy just to show you what they actually are, what the difference is. SymPy is simulation in Python. Pandas, I really didn't quite get what this was saying, but Pandas is an open source BSD licensed library providing high performance, easy to use data structures and data analysis tools for the Python language. And Number, which I thought was quite cool, is just-in-time specializing compiler which compiles annotated Python and NumPy code into LLVM. Right, and also, one that a lot of people might argue, is that it's faster than Ruby. Also, I've been told. This is basically anecdotal, or based off anecdotal evidence, but from what I have seen, Python does have a long-standing, steady, or stable user base when compared to some others. Just thinking about the uptake of Python versus Ruby. Python's always been sort of slow but steady, whereas Ruby's, since Rails came out, had this massive spike and then sort of petered off. And all that was observation that I made before I started my own journey into Ruby itself. And Python was actually the first programming language that I learned, or dynamic programming language. And for those interested, you might note that I'm saying first dynamic programming language. The first actual programming language that I learned with any amount of earnest was C++. I was young. So that was Python. How about some other languages? JavaScript. It has good parts. But okay, it actually does have good parts. Like package management. But really, we've got sort of a new addition, if you will, in the last few years. We've got transpilers in JavaScript. And I've only listed a couple here, it's the only ones I could think of at the time. We've got CoffeeScript, which is a language of its own that transpiles from CoffeeScript into JavaScript in a reasonably straightforward manner. So if you're going to write some CoffeeScript, you're pretty sure what's going to come out in the JavaScript at the end. It just sort of gets around some of the nasty bits of JavaScript for you, and sort of basically just, if we went back to the good parts, it deals with just the top. That's what it gives you. And we've also got Traceur, which takes next generation JavaScript and makes it runnable in current generation JavaScript environments. And of course, we've got this massive explosion of front-end frameworks in the last couple of years as well in JavaScript. And I've got a few examples that I mentioned here, which is basically Backbone, Ember, and Angular. It seems to me that Angular is the most divisive and infectious framework of all of these. Everybody, including myself, starts to twitch when you tell them that you're putting data into the DOM. But then after a while of using it, you get to, oh, it's okay, I guess. I haven't gotten past that stage yet, so we'll see. And also, of course, finally, JavaScript has become a first-class citizen in the back-end world with Node.js. Yeah, so currently the only open-source thing that I'm really contributing at the moment is a library called Node.sass, which is a wrapper around the libsass library. which is basically meant to be a C implementation of the Ruby Compass, which is the canonical SAS or SCSS compiler. So now we're on to one of my favorite languages, Golang. The Go language is designed for readability and maintenance. It's no fuss. Let's see. The way you format Go code is even a part of the language. So they don't let this be something that's up for discussion. It's actually defined in the language, in the tool set, that this is how you write Go code. You put your starting bracket up on the end of the line, etc. So yeah, Go has namespaces. That's cool. It's all well and good. Namespaces in Go have purpose and are enforced. I don't think you can import a single item from inside another namespace like you can in Python. Go also has awesome packaging. Basically, if it's on the internet, you can download, install, and use it directly in Go. The Go toolset can pull code from online version control or specially formatted file and folder structures. And of course, Go has a really simple way to discern between public and private. If it starts with a capital letter, then it's public. Otherwise, it's private. And there are no semicolons. And here's an example that I've just included from some code that I've written. This is actually an excerpt from a Go implementation of Pong. So it's really easy to see. This is part of the ball package. I'm importing Go SFML, which is into the SF namespace. Otherwise, if I didn't call it SF, it would just be called Go SFML2. I'm creating a ball, which is a structure, has a shape, and you can see that that shape is public because it's got a capital on the name, and that function new ball is also going to be public in the namespace of the ball package. Go also has concurrency built in, and this is much like Java, so it has some excellent concurrency primitives. And there are two main pieces to this. Channels, which are typed and for message passing, and Go routines, where any function can become a Go routine. I think I skipped a bit. There we go. Channels, so as I said before, they're a typed message passing primitive. Here's an example of one in use. We have defined, I actually ripped this out of effective Go. So we've got, first we're creating the channel, which is just an unbuffered channel of ints. So what will happen is you put an int into it, then a function will read it out, or as happens down the bottom of the line, it's just read into nothing. And go back. Go routines. You can basically make any function a Go routine, and Go routines, yeah, are lightweight. So they're green threads, but they can be backed by OS threads. By default, when you're running a Go application, you're only going to run it in a single process form or a single threaded form, but you can give it instruction to use a maximum amount of processes when running it, which will basically create a thread pool and manage your threads for you. And I've got another example there of basically trying to show how cheap these Go routines threads are. Interfaces. Now, I actually put this in after I saw the Plone talk at the Django MiniCon on Friday. Because I really like what interfaces are here. Interfaces are implicit, so you'll define an interface, which is, in this case, a reader, and then we've got a type foo, which we're only using here to define a type that will implement that interface. And then down the bottom we have the function implementation of read, which acts on, which is on foo, so you call it, foo.read. And because foo implements the read interface, or the read function, in the same way that the reader interface defines it, foo inherently or implicitly implements that reader interface. Also, interfaces are composable, which is actually something I only learnt while researching for this talk. But as you can see in the example I've given here, we've got a reader interface and a writer interface, and then we have a read-writer interface, which just by mentioning the two reader and writer interfaces, it's composing them into itself. And also, just a point of interest is that Go is not an object-oriented language. It is type-based, and it feels a lot like an object-oriented language, but there is nothing in terms of inheritance. You've only got these things such as composability. So lastly, but not leastly, we're going to move on to what is my now bread and butter, or would you call it a cookie, Ruby. So first off, I'd like to introduce you to the concept of min_swan. I'm sort of in two minds about min_swan. What min_swan means is Maths is nice, so we are nice. Basically, don't be a dick. But really, why do we need somebody else to be nice first? What if Maths was a dick? DHH certainly is. Once again, this is starting to sound very, very familiar. All the Rubies. Ruby has a lot of different, what we call Rubies, interpreters or compilers, be them as they may. So this is much like Python, except I think in Rubyland we're a lot more widely accepting of the various interpreters that are available. So we'll run through these quickly. We've got MRI, which is Maths' Ruby, and that's what most people use. REE, or the Ruby Enterprise Edition, which I hope nobody uses anymore. Rubinius, a re-implementation of Ruby in C++ and Ruby as well. JRuby, which is obviously Ruby on top of the Java stack. Iron Ruby, which is, again, something I always forget about. And Topaz, which I actually almost forgot to put in this talk, but is really cool. It is the dark horse. It is Ruby implemented in Python. So yeah, Topaz. Holy shit, this is awesome, right? Ruminate on this for a second. Ruby, written in Python, or more precisely RPython, which is your restricted Python. Wow. So I'm only a little bit disappointed that it's not Ruby implemented in Ruby? Ruby is also something that's highly touted of it in some respects is expressiveness. Mainly I'm talking about poetry mode. There we go. So poetry mode essentially allows you to drop brackets as long as it doesn't make the call chain ambiguous. So on the top here, we've got a hash, or in Python land, of course, it's a dictionary, and we're sorting through all the keys and join them together into a string. So that can be reduced to the second line, which has all the function brackets dropped off in the middle, because they don't take any parameters, they don't need the parentheses. And then, of course, down on the bottom, because there's nothing chaining on the end of join, we don't need any parentheses down the bottom there either. And while we're here, the different ways you can use hashes. So I'm only using hash new here to show that we can actually drop the brackets when we're using a hash with a function. So from the top, we're dropping the curly braces in for the second form, and then down in the third form, we're dropping the parentheses and not the curly braces, and then on the bottom, we're dropping all of them. Once again, we can only do this because there is nothing chaining on the end of the bottom line after you've created the hash. And then while we're here, again, the top code block here is actually just syntactic sugar for the second or bottom code block there, because who really wants to type in a hash rocket? And just out of interest, the top block only became valid in Ruby 1.9 and continues on Ruby 2. But a lot of people, I think most of the Rails code base still uses hash rockets around the place. So I only have a few things left for Ruby. I am trying to keep this short. Everything is an object, unless it's a method, but the method call should return an object. And I think symbols are cool. Symbols, for those wondering, are, if I can get back, what's on the left-hand side of the hash there. As you can see, it's not a string. In both instances, those are actually symbols, but you can only use a string in place of a symbol in the bottom form there. So we can catch back up to where we are. So symbols are not strings, they are their own type. They can be used outside of a hash. So any symbol that you create that looks like another symbol, has the same name, so :foo, that looks like another one called :foo, they are exactly the same symbol. So in other words, they're idempotent. And finally, I didn't really intend for this talk to have a message to carry away from it, but if there is one, it's this. Having a favorite language is pretty cool, but being reasonably competent in many is better. Don't silo yourself in one area, language, or platform. Always look to expand your knowledge, because there is no such thing as knowing enough. Cool. That is the end of my talk. Any questions?
Hi, thanks a lot. I think that's great advice to an individual developer to, broaden their mind as much as possible and learn other languages. What about a single development shop? Do you think that there's value in having multiple languages in-house, or you really want to focus on just one platform?
I see value in staying one platform for a shop. Basically because then everybody can sort of pitch in and, they can collaborate because they all know what they're doing on that one platform, or they should. But I also see value in branching out and seeing what other options there are, if there's something better suited to the job. Especially if you're if you're a web shop. You've got your Python or your Ruby, so your Rails or your Django or Sinatra, Flask, Pyramid. You've got all these options for the back end, but and that's you can silo yourself there, but then you've got a whole lot of front end stuff to do. You've got your JavaScript and you've got your CSS, and you've got many ways that you can deal with that. So maybe that's an area to branch out in first.
So you mentioned that you wrote a version of Pong in Go. I was wondering if there are any decent graphics / SDL, GL interfaces available for Go at the moment, because when I last looked, there weren't any.
So you're asking about decent graphics interfaces for for Go?
Yes, or just wondering what you were using to implement your Pong clone.
Right. So I used a Go binding to a library called SFML. I don't know if you've heard of that. SFML is basically built on top of OpenGL. It is implemented in C, or C++, I can't remember which, to be honest. But it's basically trying to be the new SDL. There are also Go bindings to SDL and directly to OpenGL as well. And I think there are actually multiple of each.
Hi, thanks for the talk. So in Python, we have PEP8 and people mostly kind of stick to that, and I guess arguments about syntax are not as common as they are in other languages, which I think is a good thing. So in Ruby, I'm curious, having 4 ways to write a function that accepts a hash, for example, Does that not just invite people arguing about trivial stuff?
Do
Do you get a lot of that?
Sorry, what was that last bit?
Yeah, do you get a lot of those kind of arguments because you can,
I
write
think
things differently?
I suppose you do get a few of those arguments, but it comes down at that point to deciding for yourself or for your development shop what is the best practice. I think most people nowadays use the GitHub best practice. So GitHub have defined somewhere on the website, I can't remember where, best practices for developing in Ruby, such as indentation by only 2 spaces, and which way you should use a hash, and whether or not to use brackets and whatnot.
So the implementation of interfaces that is in Python is not used a lot. It's used in Twisted and it's used in Zope. Do you see benefit in that being accepted into the language, or do you think it's not really missed?
I think I'd need to read a bit more, hear a bit more about interfaces as they're used in Zope or Plone before I could really give a proper answer to that. It came as a brainwave to me to include interfaces into this talk after seeing, I think it was your talk at DjangoCon. But now I can't really remember what was said, unfortunately, I'm sorry. So I don't think I can actually answer your question very well. Any more questions?
Well, I'm sure you'll still be around the con for the afternoon tea if there are any more questions. But first, PyCon would love to thank you for doing this talk. We have a lovely coffee cup.
Thank you.
And for your coffee cup, we have some lovely Norwegian blue coffee from Ritual.
Thank you very much.
Please all join me in thank you.